Good morning children, welcome to the online class. Okay, today we are discussing a very important distribution in statistics, that is normal distribution. Normal distribution is a continuous time distribution and it is also known as Gaussian distributions. Now moving to the definition of normal distribution, a continuous random variable x is said to follow a normal distribution if its PDF is given by f of x equal to 1 by sigma root 2 pi e raised to minus half into x minus mu by sigma the whole square. Here x ranges from minus infinity less than x less than infinity, minus infinity less than mu less than infinity, and sigma greater than 0. Then the random variable x is said to follow a normal distribution with parameter mu and sigma, and we write it as x follows normal distribution with parameter mu and sigma, where mu is the mean of normal distribution and sigma is the standard deviation of normal distribution. Okay, once again, x is a discrete continuous random variable, then x is said to follow a normal distribution if its PDF is given by f of x equal to 1 by sigma root 2 pi into e raised to minus half into x minus mu by sigma the whole square. Here x ranges from minus infinity to plus infinity and mu ranges from minus infinity to plus infinity and sigma greater than 0. And we write it as x follows normal distribution with parameter mu and sigma. Here there are two parameters, that is mu and sigma. Mu is the mean of normal distribution and sigma is the standard deviation of normal distribution. Alright. Now we are discussing the properties of normal distribution. There are many properties in normal distribution. First you look at the picture. This is the graph of normal distribution and it's a symmetric distribution. What do you mean by symmetric distribution? That means both the sides have same area, then we call it as symmetrical distribution. This is the shape of a normal curve. It's a bell-shaped curve and it ranges from minus infinity to plus infinity, and this is the maximum point in maximum frequency in normal distribution. Now look at the properties of normal distribution. First one, normal curve is a bell-shaped curve. Now look at the picture, that is the shape of a bell. So we call normal curve as a bell-shaped curve or a symmetrical curve. It extends from minus infinity to plus infinity. Normal curve is symmetrical about x equal to mu. That means if we put a mirror in the center line, both the sides will appear the same. So we can say that the normal curve is symmetrical about x equal to mu. That is beta 1 equal to 0. What do you mean by beta 1? Beta 1 is the measure of skewness, right? We already studied that. Beta 1 is the measure of skewness. What do you mean by skewness? Skewness is the lack of symmetry. Here there is no lack of symmetry, so beta 1 equal to 0. In normal distribution, mean equal to mu and variance equal to sigma square. Meaning, as you know, there are two parameters of normal distribution, mu and sigma. Mu itself is the mean of normal distribution and variance equal to sigma square. And obviously standard deviation is the square root of variance. So standard deviation is equal to sigma. Okay. In normal distribution, mean equal to median equal to mode. That is, since normal distribution is a symmetrical curve, the mean, median, mode are coincide with the point here. Here is the point here. Mean, median, mode will coincide. Okay, in normal distribution, QD, what do you mean by QD? QD is the quartile deviation equal to 2 by 3 sigma and mean deviation equal to 4 by 5 sigma and standard deviation is equal to sigma. Therefore, the ratio between QD, MD and SD will be 10:12:50. Alright. Now, the normal curve is mesokurtic and the measure of kurtosis is beta 2 equal to 3. In normal distribution, f of x is maximum when x equal to mu. Look at the picture. The maximum height is at the point x equal to mu. So in a normal distribution, the maximum frequency is at x equal to mu and the maximum value is 1 by sigma root 2 pi. That is, if we substitute, what's the PDF of normal distribution f of x equal to 1 by sigma root 2 pi e raised to minus half into x minus mu by sigma the whole square, isn't it? If we put x equal to mu, what will we get? X equal to mu, the whole term will become 0, e raised to 0 equal to 1. So the only remaining term is 1 by sigma root 2 pi. That means the maximum value of f of x equal to 1 by sigma root 2 pi. Alright. The points of inflection of normal curve is mu plus or minus sigma. That is, in normal distribution, 2 points of inflections, that is mu minus sigma and mu plus sigma. Normal curve touches x-axis at minus infinity and plus infinity. That is, x-axis is the asymptote of normal curve. That means here the normal curve touches the x-axis at minus infinity and plus infinity. That means x-axis is the asymptote of normal distribution. What do you mean by asymptote? Asymptote is the tangent at infinity. As you know, you have already studied in mathematics now. Now, next property is in normal distribution, odd order central moments are 0. All odd order central moments are 0 in normal distribution. That means mu 2r plus 1 is always 0 in normal distribution. In normal distribution, even order central moments are given by mu 2r equal to 1 into 3 into 5 into etc. 2r minus 1 into sigma raised to 2r. This is the even order central moments in normal distribution. Okay, these are the important properties of normal distribution. Clear? Next one is area property of normal distribution. Area property of normal distribution. In normal distribution, 90% of observations are between mu minus 1.645 sigma and mu plus 1.645 sigma. That is, this is the shape of a normal curve, isn't it? Here, mean equal to mu. At the center, we have a mean, and at lot 1.645 here, and we have minus 1.645 here, and this is the area. This is the area between minus 1.645 and plus 1.645, and the probability of getting this area equal to 90%. Alright. That is, you have to by heart this. The 90% of observations lies between mu minus 1.645 sigma and mu plus 1.645 sigma. That is, the probability of x lies between mu plus or minus 1.645 sigma is 0.90. That means 90%. Next one is in normal distribution, 95% observations lies between mu minus 1.96 sigma and mu plus 1.96 sigma. That means the probability of x lies between mu minus 1.96 sigma and mu plus 1.96 sigma is 0.95. That means 95%. That means if we part 1.96 here, we have minus 1.96 here. So this is the area, and the probability of getting this area is 95%. Alright. Now, in normal distribution, 98% of observations are lies between mu minus 2.326 sigma and mu plus 2.326 sigma. In 98%, the value of the probability of x lies between, the area of the probability of x lies between mu minus 2.32 sigma and mu plus 2.326 sigma is 98%. That means if this is 2.326 sigma and this is minus 2.32 sigma, and this will be the area, and the probability of getting this area is 98%. Alright. In normal distribution, 99 observations are lies between mu minus 2.58 sigma. So we have minus 2.58 sigma here, 2 plus 2.58 sigma here, and this will be the area, and the probability of getting this area will be 99%. Alright. So these are the properties of area properties of normal distribution. It is very useful for finding the problems like find the area under the normal curve, something like that. Okay. Next we want to find the mean of normal distribution. Okay. For finding mean, we have to find E of x. E of x equal to integral over x into f of x dx. Before that, what's the PDF of normal distribution? That is f of x equal to 1 by sigma root 2 pi e raised to minus half into x minus mu by sigma the whole square, isn't it? Here x and mu are ranges from minus infinity to plus infinity and sigma greater than 0. Alright. Then substitute here minus infinity to plus infinity x into 1 by sigma root 2 pi e raised to minus half into x minus mu by sigma the whole square into dx. Alright. Now I'll rearrange this term x as x minus mu plus mu. Alright. That is, I rewrite the term x as x minus mu plus mu into 1 by sigma root 2 pi e raised to minus half into x minus mu by sigma the whole square into dx. Alright. Okay. Now I will split the term integral minus infinity to infinity. This is the one term and this is another term. I will split these two terms as x minus mu into 1 by sigma root 2 pi e raised to minus half into x minus mu by sigma the whole square into dx plus another one is integral minus infinity to infinity mu into 1 by sigma root 2 pi e raised to minus half into x minus mu by sigma the whole square into dx. Alright. Now this is the constant term, so we can take outside 1 by sigma root 2 pi into integral minus infinity to infinity x minus mu into what's the remainder a raised to minus half into x minus mu by sigma the whole square into dx plus here mu is the constant, so can be taken outside mu into integral minus infinity to infinity 1 by sigma root 2 pi into e raised to minus half into x minus mu by sigma the whole square into dx. Alright. Now consider the term integral minus infinity to plus infinity x minus mu into e raised to minus half into x minus mu the whole square into dx. This is a odd term of x minus mu. So the integrand must be 0. So you study the property like integral minus infinity to infinity odd function is equal to 0. Then what will be integral minus infinity to infinity even function equal to 2 into integral 0 to infinity the even function. So this is some properties in mathematics regarding the functions, that is integral minus infinity to infinity and odd function. For example, in integral minus a to a odd function is equal to 0. And what about the even function? Even it is minus a to a or minus 5 to 5, minus 10 to 10, and even function equal to we get 2 into integral 0 to infinity of that integrand. Okay. So applying that property here, this is an odd function of x minus mu. So the integrand must be 0. So we get this function, odd function as 0 plus mu into, what about this function? Integral minus infinity to infinity 1 by sigma root 2 pi into e raised to minus half into x minus mu by sigma the whole square. This is the PDF of normal distribution, isn't it? So this is the total probability of normal distribution. This is the PDF of normal distribution and we integrating minus infinity to infinity. That means the total probability of normal distribution. What is the total probability of a PDF? That is equal to 1. So we get as mu into 1. That means mu. What is the mean of normal distribution? It is mu. Mu is one of the parameter of normal distribution. Alright. Next we want to find the variance of a normal distribution. We have two formulas for finding variance of a random variable, that is e of x minus e of x the whole square. Other formula is e of x square minus e of x the whole square. Okay, we usually use the second formula for finding variances of any random variables. Okay, now here we are taking the standard formula, that is expectation of x minus e of x the whole square. No need for finding e of x square. Okay. So here we take variance of x equal to e of x minus e of x the whole square. E of x is the mean of normal distribution And what is the mean of normal distribution? Mu. So we can substitute mu here, E of x minus mu the whole square. Now the formula is integral minus infinity to infinity x minus mu the whole square into 1 by sigma root 2 pi e raised to minus half into x minus mu by sigma the whole square into dx. Alright. Now 1 by sigma root 2 pi is a constant, can be taken outside. 1 by sigma root 2 pi into integral minus infinity to infinity x minus mu by sigma into e raised to minus half into x minus mu by sigma the whole square into dx. Now substitute for x minus mu by sigma as z equal to x minus mu by sigma. Put z equal to x minus mu by sigma. Okay, then what is x here? What is x here? X equal to mu plus z sigma. Then what about dx? Dx equal to mu is a constant, so the derivative of mu will be 0. Then we get sigma dz. And what about the limit? Here x ranges from minus infinity to plus infinity. When x equal to plus infinity, when x equal to infinity, z will become, substitute infinity for x here, then the value of z will become infinity. When x equal to minus infinity, then z also will become minus infinity. Substitute minus here, infinity here, we will get z equal to minus infinity. Clear? Okay, now we get 1 by sigma root 2 pi into integral minus infinity to infinity. X minus mu will be taken as z sigma the whole square into e raised to minus half into x minus mu by sigma will be z square by 2 into dx will become sigma dz. Alright, now sigma and sigma will be cancelled. Sigma square is a constant, can be taken outside. Sigma square into root 2 pi into integral minus infinity to infinity z square into e raised to minus z square by 2 into dz. Alright. Now all that x term will changes to the z term. Okay. Now z square integral minus infinity into infinity z square into this term is an even function. So we can write this as equal to sigma square divided by root 2 pi into 2 into integral 0 to infinity z square into e raised to minus z square by 2 dz. Okay. You already studied about the property of even and odd functions. So minus infinity to plus infinity and even function will be written as 2 into integral 0 to infinity z square into e raised to minus z square by 2 dz. For the easy calculation, we want to substitute for e raised to minus z square by 2. That is, put u equal to z square by 2. Okay, that is z square by 2 equal to u. Then z square will equal to 2u. For differentiating, 2z dz equal to 2 du. 2 and 2 will be cancelled. Z dz equal to du. dz equal to du by z. Instead of z, we can write du equal to z square equal to 2u. So z will become root 2u. Alright. Then what about the range? Here z ranges from 0 to infinity. Z from 0 to infinity. Then what about u? When z equal to 0, u will be also 0. When z equal to infinity, u is also infinity. Okay. So here z ranges from 0 to infinity, then u is also ranges from 0 to infinity. Clear? So we can write this as 2 sigma square divided by root 2 pi into integral 0 to infinity. Z square can be written as 2u into e raised to minus u. Dz can be written as du by root 2. Alright. Root 2 into root 2 is 2. And there is another 2 here. All these 2's are cancelled. Now we'll get 2 sigma square, another 2 here, 2 sigma square by root pi into integral 0 to infinity e raised to minus u into u. There is a root u in the denominator, then it will goes to the numerator, u raised to minus half, u raised to minus half into du. I will club these two terms, u into u raised to minus 1 by 2 will become u raised to half, isn't it? U raised to half du. Clear? Now I will write 2 sigma square divided by root pi into integral 0 to infinity. This is similar as the gamma function. You already studied about the gamma function. What is gamma function? Integral 0 to infinity e raised to minus mx x raised to p minus 1 dx equal to gamma p by m raised to p, isn't it? So I want to make this integral as a gamma function. For that I am doing e raised to minus u, and u raised to 1 by 2 can be written as u raised to 3 by 2 minus 1. Alright, 3 by 2 minus 1 is 1 by 2. Okay, so I will rearrange u raised to 1 by 2 as u raised to 3 by 2 minus 1. Okay, so this integral will become gamma function. So I can write this as 2 sigma square by root pi into, instead of p we have 3 by 2 here. So the value of the gamma function is gamma p by m raised to p. So I can write gamma 3 by 2 into 1 raised to 3 by 2. Alright, equal to 2 sigma square by root pi into gamma 3 by 2. What about gamma p plus 1? Gamma p plus 1 equal to p gamma p. Okay, so gamma 3 by 2 can be written as 1 by 2 gamma 1 by 2. Alright. Now 2 sigma square divided by root pi into 1 by 2 into gamma 1 by 2 is equal to root pi. Okay, so gamma root pi will be cancelled, 2 and 2 will be cancelled. What's the remaining term? It is sigma square. So sigma square is the variance of a normal distribution. What about the mean? Mean is mu and variance is sigma square. These are the two parameters of normal distribution. Alright. Now we are discussing about the MGF of a normal distribution. MGF. As you know, the formula for MGF is mxt equal to expectation of e raised to tx. That is, this is the definition of expectation, integral over x e raised to tx into f of x dx. Instead of f of x, we have to write the PDF of normal distribution. That is, integral minus infinity to infinity e raised to tx into 1 by sigma root 2 by e raised to minus half into x minus mu by sigma the whole square into dx. 1 by sigma into root 2 pi is a constant, so can be taken outside, and the remaining term will be integral e raised to tx into e raised to minus half into x minus mu by sigma the whole square into dx. Now we want to substitute for x minus mu by sigma as z. That is, x minus mu by sigma equal to z. X minus mu will be equal to z sigma. X will be equal to mu plus z sigma. And we have to find the derivative of x, that is dx equal to mu is a constant, so its derivative will be 0 sigma dz. Alright. Now this is a term in the variable x. Now we want to change the variable x to z. When x here, x ranges from minus infinity to infinity, then we want to find the ranges of z. That is, when x equal to minus infinity, substitute here minus infinity, then z also will become minus infinity. When x equal to plus infinity, then z will also become plus infinity. That is, z ranges from minus infinity to plus infinity. Alright, okay. Then the mxt will be 1 by sigma root 2 pi integral minus infinity to plus infinity e raised to t into, instead of x we have to write mu plus z sigma into e raised to minus z square by 2 d sigma dx is sigma dz is a sigma dz. Okay, now 1 by sigma root 2 pi into integral minus infinity to infinity. I will split all the terms, e raised to mu t plus e raised to z sigma t into e raised to minus z square by 2 sigma dz. Sigma and sigma will be cancelled. So e raised to mu t is a constant, so can be taken outside. E raised to mu t divided by root 2 pi into integral minus infinity to plus infinity, e raised to minus half into, I will take minus half outside, then the remaining term will be z square minus 2 sigma tz, and this 2 and this 2 will be cancelled, minus into minus plus sigma tz plus sigma tz. Okay, then e raised to mu t by root 2 pi into integral minus infinity to infinity. I will add adding and subtracting t square sigma square plus t square sigma square minus t square sigma square. The net resultant will be 0. Okay. So I will add plus t square sigma square and minus t square sigma square. And e raised to mu t by root 2 pi into integral minus infinity plus infinity e raised to minus half into z square minus 2t sigma plus t square sigma square. I will take 1 e raised to minus t square sigma square outside, minus into this minus plus this half will goes to e raised to minus half t square sigma square dz. Clear? Now e raised to mu t plus half t square sigma square divided by root 2 pi into integral minus infinity to plus infinity e raised to minus half into, this is half, now it's that e raised to minus half into, this is the expansion of the term z minus t sigma the whole square. So z minus a minus b the whole square, z minus t sigma the whole square into dz. That is e raised to half t square sigma square is a constant, there is no variable there. So we can take e raised to half t square sigma square outside. Alright. Now again we want to substitute for z minus t sigma. So I substitute z minus sigma t equal to u. Then dz equal to, sigma t is a constant, so derivative will become 0, dz equal to du. When z ranges from minus infinity to plus infinity, you will also change from minus infinity to plus infinity. So there is no change in the upper and lower limit of the integral. So mx t equal to e raised to mu t plus half t square sigma square divided by root 2 pi into integral minus infinity to plus infinity e raised to minus half into z minus t sigma is u square by 2 into dz equal to du. Alright. Now again I want to substitute u square by 2 as v. U square by 2 equal to v. U square will be 2v. 2u du, that is I differentiate u square as 2u du equal to 2 dv. 2 and 2 will be cancelled. So u du equal to dv, du equal to dv by u. Instead of u, we want to write u square is 2v, so u will be root 2v, root 2v. Alright. Now mx t equal to e raised to mu t plus half t square sigma square by root 2 pi into 2 into, this is a this term is an even function of u square by 2, so I will write integral minus infinity to plus infinity as 2 into integral 0 to infinity. That's a property of an even function, right? Okay. And 2 into integral 0 to infinity e raised to minus u square by 2 will become minus v, du will become dv by root 2v. Alright. Now this is root 2 into root 2 equal to 2, and this 2's will be cancelled. Okay, and the remaining term will be e raised to mu t plus half t square sigma square divided by root pi into integral 0 to infinity e raised to minus v into dv divided by root v. Root v equal to v raised to 1 by 2. That will goes to the numerator, then it will become v raised to minus half. V raised to minus half dv. Alright. Equal to e raised to mu t plus half t square sigma square divided by root pi into, I want to make this as a gamma function. So I will write minus 1 by 2 as 1 by 2 minus 1. What is 1 by 2 minus 1? It is minus 1 by 2. So I will write v raised to minus 1 by 2 as v raised to 1 by 2 minus 1 in order to make gamma function. E raised to mu t plus half t square sigma square divided by root pi into, what's the value for this? Gamma p by m raised to p. Alright, instead of gamma we have to write gamma 1 by 2 by ms minus 1 minus v ms 1 raised to 1 by 2. We know gamma 1 by 2 is root pi. So root pi and root pi will be cancelled. What's the remaining term? E raised to mu t plus half t square sigma square. Okay, so this is the mxt, that is mgf of a normal distribution. What is e raised to mu t plus half t square sigma square? Clear?